Hello students, this is chapter 4, the role of the technologist. And what a role it is. There is a lot that a mammography tech has to do just during a short period of time to get that exam done. And we're going to talk a little bit about that in this chapter. The goal to detect breast cancer in its early stage has been assisted by the evolution of premium breast imaging options. For the majority of the cases that require ancillary breast imaging modalities, the process begins with that screening or diagnostic mammogram. The technologists performing mammography in the United States must adhere to strict federal requirements of the Mammography Quality Standard Act, as well as the state of California. This chapter takes a closer look at the critical role of the mammotech in the breast health care service as she endeavors to meet professional expectations that include her responsibility to the patient and to the other members of the healthcare team. So as we all know, ARRT has advanced certifications in several areas. In the United States, over 300,000 registered technologists have an ARRT advanced certification. Of those 300,000, close to 50,000 of them are in mammography. So to begin talking about the role of the technologist, becoming a mammography technologist is what you're doing right at this time, is going to require 40 hours of initial training. There's going to be apprentice training, so as you all know, you need a total of 100 supervised mammography exams performed to sit for the ARRT and the state test. You need to be able to work independently, and you need to practice continuing experience, and you have continuing education requirements. There are rules and regulations that we must follow, as I mentioned, for MQSA in the state of California. And as a member of this team, the mammography team, there's going to be technical demands that are put on the technologist and emotional demands, as we will find as we move forward in this lecture. So technologist duties start with confirming that you have the correct patient. Always check 2 forms of ID. As an example, make sure that the patient gives you their full name and tells you what their date of birth is so that you can verify. Verify that it's the correct procedure. Make sure that it's an asymptomatic person that's getting a screening mammogram versus somebody that has symptoms for a diagnostic mammogram. If you're doing an interventional study, such as a biopsy, you want to make sure that it's in the correct breast and you're going after the correct mass or lesion. It's important to verify information on a breast history form. As you can see on this slide here is an example of one. We want to ask many questions, and we want to mark any landmarks on the diagram at the bottom of the breast history form. This is all to help our radiologist during the time of interpretation. On the history form, the reason we need to be so detailed and complete is because most of the time the radiologist will never see a screening patient. So they're going to rely on the information that you, as the mammography technologist, shares with them. And so therefore it's important to be complete with the history form and really listen to your patient, because many times they're going to give you additional information that you want to pass on. The radiologist may or may not see diagnostic patients, so this is important for diagnostic patients too. I think in most instances, at most facilities, you will find that the radiologist will interface with diagnostic patients, but still, it's always good to have this documentation. So the radiologic technologist is acting as an agent through the observation and communication to obtain all this information to pass on to the physician to make for the most complete and quality diagnosis. So technologists are going to do a lot in a 10 to 20 minute appointment slot. You can say you're balancing a lot of things, you're keeping a lot of balls up in the air, so to speak. So the technologist is going to balance during that time image quality, the patient experience, how well her interpersonal skills are helping with patient satisfaction. Is the equipment working correctly? Is the positioning and compression skills where they need to be? So let's talk about image quality first. The equipment. So the equipment is ensured to be operating correctly by routinely being monitored by a medical physicist through his or her testing. This is done at least annually. If a unit is repaired significantly or upgraded, or you've moved it from one site to another, you're going to have a medical physicist do testing at that time also. The other testing that goes on will be quality control testing that you'll learn more about in future chapters. The technologist is required to perform. The sites may share those duties of quality control between the mammography techs, or they may have specifically assigned QC technologists. The technologist actions and how they review the images to make sure that they are sending quality images to the radiologist for interpretation is required during this time. Then there's the patient experience, and all this is done simultaneously. You want to make sure that the patient is satisfied, that you are communicating to the patient appropriately to help the patient do the best that they can for you in the positioning and accepting whatever the compression discomfort is. You do become, we used to say, you're like doing the mammography dance, you and the patient. And when you start positioning in mammography, you'll see why we call it the mammography dance. But you really have this teamwork that's going when you're working together. And all of this is done in a very short amount of time. The technologist's job entails far more than the positioning and the compressing of the breast. She has to contain the technical skills and equipment operation skills to maintain high quality images. The technical skills, of course, are your positioning and the compressing of the breast. She also needs to understand all the different special views and additional views that can be used depending on what the radiologist needs to see specific anatomy or pathology, or depending on a patient's unique body structure, you may need to get very creative with your positioning. And so it's important for a good technologist to understand all of those tools that they have in that tool belt. And then equipment operation. You want to make sure that all of the bells and whistles on that piece of equipment you are very familiar with and know how to use those, because we as humans come in all kinds of different shapes and sizes, and so you really need to understand what you can do with this equipment. And then, as we've talked earlier, the customer experience is so important. So the communications and interactions with your patients, they need to be calm and soothing, but very informative. And you need to make sure that the patient feels confident in your expertise, your level of competency in doing the exam and preparing her for the exam. And then there needs to be the skills of evaluating that image quality. You know, did you get a good study? Can you proceed on to the other views? Can you say that the exam is done? Is it appropriate to now send that image over to the radiologist? So when we measure quality services, it's broken down into three categories. There is the perceived quality, and this is a very subjective quality recognition by the patient. It's the impression that the patient forms about the service they received. So, for example, If everything went well in the beginning, but when they got back into the mammography suite, if that technologist is not being very open with the patient and sharing the information and coaching her through the process, they may decide that the service was very suboptimal. Patient satisfaction achieved when the patient feels that the actual quality received surpasses their expectation of quality. So we want the patient to feel like we at least met their expectation, but ideally we want to surpass it. Expected quality. This is a quality expectation that is formed by the patient before they come to the facility, and it's formed by them hearing word of mouth of a mammography exam by their friends or family, and also what they see on TV or hear on the radio. There's going to be all that information out there. So really, we don't, as technologists, have any influence at this point. But if you think about it, you can think that everybody always talks about how painful a mammogram is because their breast is compressed. So people that haven't had a mammogram before, they're going to come in frightened and worried about having that mammogram because they've heard so much about the pain that a patient experiences with a mammography. So that is an expected quality. Actual quality is your statistical data. This is what we get after everything is said and done. It's what kind of sensitivity and specificity of the radiologist's interpretation are we getting? What are our recall rates? If the standard recall rate in the United States is 10%, is our facility above that or below that? And what does that mean? What is the size of detected cancers that we're finding on our screenings? Of course, we want those to be as small as possible. And then we want to look at our referring physician satisfaction. Are they happy with the reports that they're getting? Are they hearing good things from the patients? Are we being as accessible as possible? That's important for us to hear back from them to know if we are providing the quality that they expect. And also, we're going to have results back from customer satisfaction surveys. So the role of the technologist is achieving image quality. And as we talked in the prior slides, it involves the technologist to be able to do many things. First of all, there's the technologist proficiency, and that includes what kind of mammography education did the technologist receive? What kind of oversight does the radiologist have on the techs in the facility, and what kind of ongoing feedback does the radiologist provide to the techs? What is the quality and length of time that the technologist had when they had supervised positioning or supervised exams done? So as an example, those 100 studies that need to be supervised, what was the quality of coaching and direction that was given to the technologist? And then when you're on the job, what kind of guidance is received from the senior mammography techs? That's where we want to learn from, are those that have been in the field for a very long time and they can pass so much information on to us. And then finally, what kind of refreshers in positioning techniques are offered to us when we're on the job? Those will all play into the technologist proficiency. The other area to achieve image quality to look at is image management. This is the ability of the technologist to recognize when additional imaging is necessary to provide a quality exam. So for example, the technologist must be able to recognize, hey, I'm not getting all of the tissue on that CC. What do I need in addition to get more tissue on the CC view? Do I need to do an additional view of the tail of the breast? Do I need to do a cleavage view to see the medial aspect better? That is exam management. And then there's adequate examination time. We want to make sure that there is a proper time slot allowed for the entire exam. And the entire exam includes going over that history form with the patient, doing the exam, and then checking images for quality. So the industry standard for digital mammography right now is 15 to 20 minutes. But I can tell you it'll vary from site to site. Some facilities may be doing screening mammograms in 10 minutes. Some sites may be doing them in more than 20 minutes. It just depends on the site, but the standard out there is 15 to 20 minutes. We need to look at the image quality checkpoints. This is where a technologist needs to make sure, are the prior studies available? In mammography, we have to have those prior studies. We want to be able to look and see, oh, what we're seeing today, did we see that last time? Or is this brand new? Are we getting as much tissue on the images as we did last time? We want to be able to look at what type of changes we're seeing in the woman's breast. So we need to make sure that those prior studies are available. And we want to make sure that when we compare today's images with the prior images, that the quality of the images are at least as good as, but hopefully better. Never subpar compared to the priors. And then we always want to make sure that the P&L rule, posterior nipple line rule, is always checked while the patient is still in the department. Because if we're way off on that rule, we need to do some more imaging. And then there's the radiologist supervision and guidance. This establishes the expectations of the radiologist. They have to tell us what their expectations are. And they have to have ongoing feedback with the techs so that the techs know what's good and what's not so good. This is very important to have that ongoing feedback. And then finally is the continuous quality improvement. Continuous quality improvement is broken down into 3 parts. There's the pre-exam. This is where the technologists make sure that they have the correct patient, that we're doing the correct exam, and we reduce the anxiety that the patient is feeling through our calm demeanor and explaining things thoroughly. Then there's during the exam. This is where we are properly positioning and compressing the breast. We are working to achieve the ACR quality standards, and we are using our competency to understand when we need to modify an exam as needed for certain patients' conditions. And then the last is the post-exam improvement, and that is the comparison of the images to the prior exam to make sure that the exam is as good as or better, hopefully better, than the prior exam. And then we want to verify that we have adequate or superior image quality by looking at our study before it's finally sent off to the radiologist for interpretation. So I think that gives you a real quick overview of what is being done during that period of time that the technologist is performing mammography. We will delve into all of these areas much more in detail as we proceed through our course. But for now, please read the chapter and do your assignments, and we'll talk to you at the next chapter. Thank you.